Welcome to this video on graphing linear inequalities. By the end of this video, you should be able to determine whether or not a coordinate point is a solution to a graphed inequality. You should be able to use the correct line type, solid or dotted, for a given inequality, and you should be able to shade a graphed inequality correctly based on the sign. So let's get into it. Up until now, we have been graphing lines. This is very similar, but linear inequalities have shading involved with them because there's more than one solution that can make the inequality true. So a linear inequality is similar to a linear equation, but instead uses your inequality symbols. So remember, we had less thans and we had greater thans. All the ordered pairs that make an inequality true are the solutions. Couple ways you can find them. One, if you plug in x and y into the inequality and it's true, the ordered pair is a solution. If you have the graph of a linear inequality, an ordered pair that is in the shaded area, which you'll find out about, if the point is in the shaded area, then it is a solution. So let's first try this algebraically, which we have done previously with one variable inequalities. If we take a point, remember a point is made up of an x value and a y value. And we're going to plug them in to this inequality here and here and solve to see if it makes sense, if it's true or not. So I have 2 times x. Well, in this case, the x is going to be 2 minus 3 times 5. And I want to know, is that going to be less than 15? So 2 times 2 is 4. Negative 3 times 5 is minus 15. Less than 15. 4 minus 15 is negative 11. Is negative 11 less than 15? It is. That means 2, 5 is a solution. Okay, let's try this next one. We're going to take the same inequality. 2 and the x value this time is negative 1. Minus 3, where a y value is negative 7. Is this going to be less than 15? 2 times negative 1 is negative 2. Negative 3 times negative 7 is a positive 21. Is this going to be less than 15? I don't think it's going to be. That's a pretty big number. So negative 2 plus 21 is 19. And that is definitely not less than 15. So negative 1, negative 7 is not a solution. All right, try it again. Actually, let's have you pause the video and try this one on your own. Come back when you're done. All right, so I plugged in 3 and negative 4, and I ended up with 18 less than 15. That's not true. So 3 negative 4 is not a solution. We'll save the last one for in class. All right, so when we go to graph an inequality, there's a couple things we need to remember, just like when we graphed the one variable inequality on the number line. When we're going to graph, it's going to be easiest to graph in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. So you're going to want to solve for y if necessary. In this case, it won't be equals. There'll be an inequality sign there. And remember, whenever you're solving an inequality, if you multiply or you do divide by a negative sign, it's going to flip your inequality to be the other direction. So there's a couple things. When we graphed our one variable inequalities, we used open circles and closed circles. Well, because we're graphing lines, we essentially have an open line and a closed line. So if we're going to have a closed line or a solid line, so that's how we normally draw them, just a nice solid line, that is going to be anytime you have the equals to in your inequality. However, if you don't have an equals to, you just have a less than or a greater than, you're going to use an open line or a dotted line like this. That means it's not equal to it. Any point on that line will not be included in the solution, but on the solid line, any point on the solid line is part of the solution. And here's where it's different than just graphing a line, is we have to shade. So if we have this symbol greater than or greater than or equal to, we're going to shade above the line. And if we have the symbols less than or less than and equal to, we're going to shade below the line. So it seems like a lot to remember, but it's not too bad. Let's give it a try. So I want to graph this inequality on here, and then I'm going to answer some questions about whether the point is a solution or not. So remember, we want to be in slope-intercept form, so we are trying to get y alone. So let's subtract the 2x to get us started. And I end up with negative 3y is less than, and we're going to write the other side in standard form with the x first. Negative 2x plus 15. Now I want y by itself, and there's a negative 3 times that y, so I'm going to divide by negative 3. Everything gets divided by negative 3. This cancels to a positive 1, leaving the y. I divided by a negative number, so my inequality changes direction. Those are both negative, so it becomes positive. And positive 15 divided by negative 3 is negative 5. Now, to graph it, it's going to look an awful lot like we used to do. We're still going to start at our y-intercept. 1, 2, 3, 4, 5. Put your first point. And now my slope is a positive 2, so that's up. My 3 is also positive. X is to the positive or right. So I go up 1, 2, right 1, 2, 3. Okay, 1, 2, and I'm going to run out of room, so that doesn't really help me. But before I draw my line, remember I had a choice on the kind of lines that I'm going to draw. I can have a dotted line or I can have a solid line. All right, so when I look at my inequality, it's not equal to, and because it's not equal to, I need an open line, a dotted line. So I'm going to make a dotted line, okay? And it really keeps going each direction. We're just looking at a small piece of it. Now the shading. This says all of your y values are greater than the line. So here's the line, and I like to look at the y-intercept. Where are the y values greater than that number? Up above it. And so anything above that line is going to get shaded in. So I'm just going to come in here and do some shading. So what that means is any point in this shaded area, and really this goes on forever and ever, any point in there will make our inequality true. So let's take a look. Is 0, 0 a solution? Well, 0, 0 is right there. It's in the shaded. So yes, 0, 0 is a solution. All right, how about 0, negative 5? 0, negative 5 is right there. That is on the line, but the line is dotted. So no, because the line is not included in the solution set. All right, let's try another point. 4, negative 4. 1, 2, 3, 4. 1, 2, 3. See how that's not in the shaded? So this is not a solution. Okay, let's flip these over and take a look at the back. All right, let's take a look at this top one. What's nice here, it's already in slope-intercept form, so we can jump right into graphing. The negative 5 is our y-intercept. 1, 2, 3, 4, 5. And my slope is a positive 1 over 3. So the positive 1 means go up 1, and it's a positive 3, so go right 3. So up 1, right 1, 2, 3. Up 1, right 1, 2, 3. Up 1, 1, 2, 3. Remember, if you wanted to go the other way, instead of up and right, you'd go down and left. 1, 2, 3. All right. So now you got to remember, are we doing a dotted line or a solid line? We're not equal to. That means we have an open line, which is dotted. Okay. And this says my y values are greater than the line. So where would y be greater than this line? The y values are greater above it. So this is where I'm going to shade. Anything in the shaded area will be a solution. So we're going to check some points. 0, 0. It's very much in the shaded area, so yes, it's a solution. Is negative 5 negative 1? 1, 2, 3, 4, 5. Negative 1. It's in the shaded area, so yes, it is a solution. How about 4, negative 7? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Not in the shaded area, so it's not a solution. All right. Let us try, we're going to skip this one, we can use it to review in class. I have some special lines here that I want you to see. So we have y is less than negative 4. So remember, y is less than negative 4. A y and a number, that's telling you to go through the y-axis at number 4, negative 4. So 1, 2, 3, 4. So you're going to go through at negative 4, and you need to have an open line because we're not equal to. So we're going to make a dotted line. Okay. Now, where are the y's less than that line? They're less than the line below it. So this is my shaded region. And same as always, I want you to test the points, pause the video, test the points, and come back and see how you did. All right, so 0, 0, not in the shaded area, not included, is 0, negative 4. 0, negative 4 is on the line, but the line is not included because it's not in equal to symbol. So 0, negative 4 is not a solution. And 4, 3, again, not in the shaded area, so it's not a solution. All right, for our last one, we have another one of these special lines. We have x is greater than or equal to 7. That says go through the x-axis where it is 7. So here's where x is 7. We're going to use a solid line because it's included in our solution. Okay, so we're just going to have a nice solid line. Draw your arrows on the ends of it. And then x is greater than 7. So if 7's here, where the x is greater than 7? To the left or to the right? In this case, it's going to be to the right because those numbers are greater than 7. So our shading is going to be over here to the side. Right there. I had my line off a little bit, so just ignore that second line. Same process is 0, 0 in the shaded area. No, it is not, so it is not a solution. How about 7, 0? Here's 7, 0. It's on the line, but the line is included. So yes, 7, 0 is a solution because it's included with the line. How about negative 5, negative 2? Right here, not in the shaded area, and not a solution. All right, we'll see you in class.